HarperCollins presents Black Holes by Professor Brian Cox and Professor Jeff Forshaw, read by Professor Jeff Forshaw. Black Holes comes with a downloadable visual PDF of figures, which will be referred to throughout this audiobook.
Chapter 1. A Brief History of Black Holes. A knowledge of the existence of something we cannot penetrate, of the manifestations of the profoundest reason and the most radiant beauty. It is this knowledge and this emotion that constitute the truly religious attitude. In this sense, and in this sense alone, I am a deeply religious man. Albert Einstein. At the heart of the Milky Way, there is a distortion in the fabric of the universe caused by something 4 million times more massive than our Sun. Space and time are so warped in its vicinity that light rays are trapped if they venture closer than 12 million kilometers. The region of no return is bounded by an event horizon, so named because the universe outside is forever isolated from anything that happens within. Or so we used to think when the name was coined. We have named it Sagittarius A star, and it is a supermassive black hole. Black holes lie where the most massive stars used to shine, at the centers of galaxies and at the edge of our current understanding. They are naturally occurring objects, inevitable creations of gravity if too much matter collapses into small enough space. And yet, although our laws of nature predict them, they fail to fully describe them. Physicists spend their careers looking for problems, conducting experiments in search of anything that cannot be explained by the known laws. The wonderful thing about the increasing number of black holes we have discovered, dotted across the sky, is that each one is an experiment conducted by nature that we cannot explain. This means we are missing something deep. The modern study of black holes begins with Einstein's general theory of relativity, published in 1915. This century-old theory of gravity leads to two startling predictions. First, that the fate of massive stars is to collapse behind an event horizon to form a black hole, which will contain a singularity. And secondly, that there is a singularity in our past which constitutes, in some sense, a beginning to the universe. This remarkable sentence appears on the first page of a seminal textbook on general relativity, the large-scale structure of space-time, written in 1973 by Stephen Hawking and George Ellis. It introduces evocative terms, black hole, singularity, event horizon, which have become part of popular culture. It also says that at the end of their lives, the most massive stars in the universe are compelled by gravity to collapse. The star vanishes, leaving an imprint in the fabric of the universe. But behind a horizon something remains, a singularity, a moment rather than a place, when our knowledge of the laws of nature breaks down. According to general relativity, the singularity lies at the end of time. There is also a singularity in our past, which marks the beginning of time, the Big Bang. We are asked to accept the profound idea that our scientific description of gravity, the familiar force that governs the behavior of cannonballs and moons, is at its heart concerned with the nature of space and time. It's not obvious that gravity should be related to space and time, let alone that seeking to describe it in a scientific theory might lead one to contemplate the beginning and end of time. Black holes take center stage in exploring this deep relationship because they are gravity's most extreme observable creations. They are so intellectually troublesome that well into the 1960s many physicists felt that while black holes are a feature of the mathematics of general relativity, nature would surely find a way of avoiding creating them. Einstein himself wrote a paper in 1939 in which he concluded that black holes do not exist in physical reality. Einstein's illustrious contemporary, Arthur Eddington, put it in rather pithier terms. There should be a law of nature to prevent a star from behaving in this absurd way. Well, there isn't, and they do. We now understand that black holes are a natural and unavoidable phase in the lives of stars, a few times more massive than our Sun. And since there are millions of such stars in our galaxy, there are millions of black holes. Stars are large clumps of matter fighting gravitational collapse. In the early stage of their lives, they resist the inward pull of their own gravity by converting hydrogen into helium in their cores. This process, known as nuclear fusion, releases energy, which creates a pressure that halts the collapse. Our Sun is currently in this phase, converting 600 million tons of hydrogen into helium every second. It's easy to skim over the very large numbers in astronomy, but we should pause and marvel at the terrifying difference in
Sample complete. Ready to continue?